Welcome back to the workshop. We will continue the workshop with Module 9 on flexible pavement rehabilitation. Module 9 will overview the flexible pavement rehabilitation design strategies for flexible pavements. Module 9 is grouped into 4 different parts. Part A, this part, will overview the condition assessment of flexible pavements and begin the rehabilitation design discussion. Part B will go through the software for flexible pavement rehabilitation design. Part C will explain the modules, models, and transfer functions, as well as the rehabilitation input levels for flexible pavements. And Part D will describe and explain the individual rehabilitation strategies for flexible pavements. There are 7 learning objectives for Module 9 in total. The first objective is to describe the models and transfer functions specific to asphalt pavement rehabilitation. The second is to describe the flexible pavement rehabilitation design strategies. The third is to identify differences between flexible pavement rehabilitation design and new flexible pavement design. The fourth is to describe the different rehabilitation design levels. The fifth is to list the important factors to consider in the design of surface modifications for asphalt pavements. This item 5 is for basically structurally adequate asphalt pavements. Objective number 6 is to list important factors for consideration in the design of asphalt overlays of existing flexible pavement. These are asphalt structural overlays where the flexible pavement is marginally adequate. And then finally, objective 7 is to list the important factors in the design of concrete overlays of flexible pavements. There are 2 sections in Chapter 12 on rehabilitation design strategies that include information related to the rehabilitation design of flexible pavements. Section 12.2 provides information on rehabilitation design with asphalt overlays, and Section 12.3 provides information on rehabilitation design with concrete overlays. We basically reviewed these 2 sections under Module 8 on rigid pavement rehabilitation designs. However, we will review this information in Chapter 7 from a flexible pavement rehabilitation design standpoint. So now let's open the MEPDG Manual of Practice, and we'll go down to Chapter 12 on rehabilitation design strategies, specifically 12.2, rehabilitation design with asphalt overlays. So this section includes information specifically for asphalt overlays or designing rehabilitation strategies with asphalt overlays that is applicable to both flexible and rigid pavement designs. So we covered some of this, as I noted earlier, under Module 8, but there's also, this information also applies to the rehabilitation of flexible pavements using asphalt overlays. Figure 12-2 lists the existing types of pavements and also then identify some of the pre-overlay treatments as well as the overlay analysis. Section 12.2.3 provides information to determine condition of the existing pavement, which is very important to determine whether the existing pavement is structurally adequate or inadequate for the site conditions and traffic levels expected into the future. There is a section 12.2.4 on deciding about pre-overlay treatments, what type, and if they're needed, and that is specifically identified or given for different types of pavements. Table 12.2 provides the overall adequacy, and then there's some general information on the pavement condition in terms of the ratings, and then the rehabilitation items to consider with or without pre-overlay treatments. Again, this really applies to both flexible as well as rigid pavements in the table, as summarized here in table 12.2 and 12.3, but it also provides very specific information on the different types of distress and what can be done in terms of candidate treatments for developing a rehabilitation design strategy. So the designer user is very much encouraged to review section 12.2 as well as section 12.3 for getting information before starting the rehabilitation design strategies for flexible pavements. Section 12.2.5 provides information on the determination of the damage modulus of bound layers. We will cover this information in this module, Module 9. This is simply just a quick overview of the different sections and information in Chapter 12, again, both for flexible as well as rigid pavements. So 12.2 is on the asphalt overlays of flexible and rigid pavements, and then section 12.3 is going to be on the PCC overlays of flexible and rigid pavements, as shown here. So again, this is important information that the user and or designer should review in determining the types of rehabilitation strategies or the pre-overlay treatments are needed for different types of pavements, as well as how that information is used in doing the rehabilitation design. Module 9, the one we're in now, is specific to rehabilitation design of flexible pavements. So after the user and or designer goes through this information, then we'll go back and continue with the presentation. So Module 9 has 7 different topics or module contents. The first is condition assessment of flexible pavements. Second is flexible pavement rehabilitation design. And sections 1 and 2 are considered Part A. Part B is the end of section 2, where we'll go through the software specifically. And then section or Part C starts with the end of the flexible pavement rehabilitation design and also includes rehabilitation design input levels for flexible pavements. Parts 4 on surface modification of asphalt pavements that are considered to be adequate, and then 5 on the asphalt overlays or structural overlays of flexible pavements. Item 6 on the concrete overlays of flexible pavements. And then 7, summary. Parts 4, 5, 6, and 7 are considered Part D in terms of Module 9. We will start with the condition assessment of flexible pavements. And as you will remember from Module 7 on an overview of pavement rehabilitation, Module 7 discussed the use of distress surveys to define the type, amount, and severity of distress. Also reviewed and discussed non-destructive tests to define the in-place stiffness and or moduli of the different layers, material sampling and testing, and a visual examination of the layers, cores, as well as material recovered from the unbound layers to define subsurface anomalies, and then laboratory testing to determine the condition of the existing pavement layers. This information will also be used within Module 9 on flexible pavement rehabilitation design, as it was under Module 8 on rehabilitation designs of rigid pavements. Assessing the pavement condition as explained and described in Module 7, the MEPDG Manual of Practice in Chapter 9 can be grouped into 7 basic areas. The first is initial pavement site feature assessment, surface property surveys, preliminary site investigation plan, and then amount and severity of distress, non-destructive test, material sampling, testing, and visual examination of layers, and then laboratory testing. Module 9, as in Module 8, we're going to focus on the last 4 items. Amount and severity of distress, non-destructive test, material sampling, testing, and visual examination of layers, and laboratory testing. Because each of these items provides key inputs for rehabilitation design, both for rigid as well as flexible pavement design. Module 9 obviously is going to focus on flexible pavement design itself. As also noted in Module 8, there are project-level pavement evaluation factors, some of which are directly used in pavement evaluation, and other factors are indirectly used in pavement evaluation to determine an assessment of the existing flexible pavement. The direct factors include such items as determining the structural adequacy of the pavement, functional adequacy of the pavement, looking at materials durability issues, and then other items such as miscellaneous type factors that could include things like raveling at the surface, cracking, severity and conditions, other types of material-related distresses that are at the surface, for example, flushing and bleeding, and those types of items. The indirect factors include items such as drainage adequacy for the any drainage ditches, curb and gutter, anything related to do with the drainage adequacy of the pavement from a surface standpoint as well as from a subsurface standpoint. Also, the shoulder condition, variation along the rehabilitation project, and other constraints. Constraints would include whether we have curb and gutter, whether there's guard rails present, and whether there's any clearance issues from bridges and or overpasses that need to be considered in establishing a rehabilitation strategy, design strategy for the existing flexible pavement. And one of very important items from the project evaluation and condition assessment task or activity is to determine the detailed or conduct a detailed distress survey to determine the type, amount, and severities of distress that have occurred along the rehabilitation project length. The Pavement ME software does require specific inputs from a distress survey to quantify the conditions of flexible pavements. Those inputs will be discussed in this module, Module 9. Visual distress surveys is an important step for flexible pavement rehabilitation. The purpose of the distress survey, as we just noted, is to quantify the type, amount, and severity of the surface distress observed along a project. The Distress Identification Manual is a document that can be used as a systematic procedure for identifying and quantifying the distress magnitude and severity levels. The MEPDG Manual of Practice suggests that the Distress Identification Manual be used to establish on a consistent basis the types, amount, and severity of the distress located along the project considered for flexible pavement rehabilitation. Another very important activity or step is the deflection testing for rehabilitation design. Deflection testing provides a very good technique to identify areas with excessive deflections and or to identify soft spots for pre-overlay repairs, especially if those soft spots are localized along the project. Also from deflection testing, determining the variability or the amount of variation along a project. In addition, deflection testing can also be used to segment the project into design or analysis sections. If you remember from the early part of this workshop, under Module 4 on inputs, one of the key items is that the average material properties or layer properties are the inputs to the Pavement ME design software. So if we have a lot of variation along the project, this just means that it will be difficult to identify an adequate rehabilitation strategy for the entire rehab project. However, using deflection data to segment the project into the pavements with similar pavement responses in terms of deflection basins, we can determine better or more applicable rehabilitation design strategies for a specific segment, and then determine the average input or average layer properties for each of the individual segments. So deflection testing is an important activity for any rehabilitation design project. Deflection testing can also be used specifically to provide inputs for the rehabilitation design. Kind of as an example, the asphalt elastic modulus can be back calculated and used in the rehabilitation design. It's a direct input to the Pavement ME software. In addition, the base course modulus or a stabilized base layer modulus can be back calculated and also used in the rehabilitation design. The subgrade modulus, back calculated from deflection testing or deflection basins, can also be used along the project and is used in design. In fact, the back calculated layer moduli from the deflection testing can be a method to segment the project into areas that have similar back calculated layer moduli for the rehabilitation design. And again, as we mentioned earlier, the back calculated elastic layer modulus are a direct input to the Pavement ME design software. Another important use of deflection testing is to measure and determine the load transfer efficiency of transverse joints and or cracks, specifically transverse cracks in existing flexible pavements. In addition, it can also be used to define the load transfer efficiency in underlying jointed plain concrete pavements in terms of the transverse joints in those concrete pavements. And that can be and is an input to the Pavement ME design software, both for the rehabilitation of concrete pavements as well as for semi-rigid pavements. But it can also be used, as noted in the photo, to determine the low transfer efficiency of transverse cracks in flexible pavements. Results from the condition assessment are used to determine an appropriate rehabilitation strategy to fix and repair the flexible pavement so the distress does not reoccur within the rehabilitation design period. Within this model, we will discuss strategies that can be used from strategies that can be used from flexible pavements that are considered to be structurally adequate, marginally adequate, and structurally inadequate. Obviously, asphalt pavements that are considered structurally adequate and only have minor distress levels would only need surface modification with or without non-structural overlays. As the asphalt pavement becomes marginally inadequate, then asphalt overlays with or without pre-overlay repairs can be needed. As additional damage occurs in the asphalt pavement, and that pavement is considered weaker, asphalt structural overlays or concrete overlays and or cold-in-place recycling may be needed as a rehabilitation strategy. Pavements that are considered totally inadequate and have severe extensive distress surveys may require full depth reclamation or very thick asphalt and or concrete overlays for ensuring that the observed distresses will not reoccur within the rehabilitation design period. This is Table 9-9 in Chapter 9 of the MEPDG manual. There's a similar table that we discussed in Module 8 for rigid pavements. This table, Table 9-9, is for flexible pavement. It provides an overview and suggestions for classifying the condition of the flexible pavements in terms of functional classification for different distresses. It provides suggestions on whether for a specific distress, that distress or flexible pavement, existing flexible pavement, is considered inadequate or poor, or marginal or in a fair condition, or is considered adequate and in a good condition. relative to the different flexible pavement distresses that can be used in the rehabilitation design. So the next section of the Module 9 is on flexible pavement rehabilitation design itself. Module 9, or the focus of Module 9, is on what is different between new flexible pavement design and flexible pavement rehabilitation design. Flexible pavement rehabilitation design, this section includes information on the models and the transfer functions specific to flexible pavement rehabilitation, which are explained and discussed in this part of Module 9. But first, the material properties of the asphalt overlays and existing layers are basically the same as for new flexible pavement design. The material properties or layer properties were discussed in Module 4-4 for each of the different layers on the inputs to the Pavement ME design software. What the inputs represent can be different, and how the properties, the layer properties, are determined can be different between rehabilitation design as opposed to new flexible pavement design. So parts of this module will focus on those differences and how those specific layer properties are determined, what they represent as inputs to the Pavement ME design software. In addition, as we just mentioned, the models and transfer functions are the same, and the mathematical operations are the same as for new pavement design. The rigid pavement models and transfer functions presented in Module 5 apply to the concrete overlays of flexible pavements, while the flexible pavement models and transfer functions presented in Module 6 are the same and representative of the models used to predict distress of asphalt overlays of flexible pavements. So we've already discussed the basic models and transfer functions for both rigid and flexible pavements in terms of rigid overlays and asphalt overlays of flexible pavements. Now, the flexible pavement rehabilitation options can be grouped into three basic design strategies. The first is surface modifications with or without non-structural asphalt overlays. In other words, the pavement is considered to be structurally adequate, very minimal levels of distress. The reason for the pavement, the flexible pavement being rehabilitated could be related to localized areas exhibiting distress or other non-structural distresses observed at the surface that have an impact more on the functional performance rather than the structural performance. These could include like raveling at the surface, bleeding and flushing of the asphalt in the wearing surface, and other surface-related stresses that do not affect the structural condition of the flexible pavement. The second strategy or group of strategies is the asphalt structural overlays. Those are classified into two parts. The first asphalt overlay or first overlay rehabilitation to be placed on the flexible pavement, and then a condition where multiple overlays exist on the flexible pavements. In other words, an asphalt overlay, one or maybe two asphalt overlays, have already been placed on the flexible pavements, and we're designing the second and or third overlay for that flexible pavement. And the flexible pavement is considered to be in a marginal structural condition or inadequate condition. And so the second basic design strategy or for asphalt structural overlays. The third category or group of rehabilitation design strategy is for concrete overlays. These would include jointed plane concrete pavement overlay of a flexible pavement, continuously reinforced concrete pavement overlay of the flexible pavement, and what's termed a short jointed plain concrete pavement overlay of flexible pavements. So these are the basic different design options that can be used in terms of flexible pavement rehabilitation. The options for asphalt overlays of flexible pavement are basically selected in terms of the condition, overall condition of the flexible pavement. And these are again further grouped into specific activities. Milling the asphalt surface or the existing asphalt surface to remove some surface distress, especially if that surface distress is confined to the wearing surface. Then you possibly using hot in place recycling techniques, again for surface distresses that are confined to the wearing surface. And then cold in place recycling, which include for flexible pavements that are marginally inadequate. In other words, the distresses, the cracking observed at the surface do propagate into the lower pavement layers, or we have deficiencies located below the surface, anomalies that exist below the wearing surface layer. And then full depth reclamation, where the flexible pavement is totally inadequate. The lower photograph would include a condition where full depth reclamation is a possibility because of extensive and severe distress is observed on the pavement structure. The cold in place recycling is more for where the distresses have started to increase in area and extent, or severity and extent, and those distresses propagate below the surface, and or there are potential anomalies, material defects located below the surface. So selecting the options for asphalt overlays of flexible pavements are obviously dependent upon the condition of the existing surface, basically the structural condition of the existing pavement. And the key mechanistic empirical based issue is completing a structural evaluation or a pavement evaluation to determine the structural characterization of the existing pavement so that an appropriate rehabilitation option can be selected for the flexible pavement to fix the problem and prevent it from reoccurring within the rehabilitation design period. This is a table that summarizes the different structural classifications of the existing asphalt or flexible pavements. Milling the surface, where that mill's thickness is excluded from the modified layer, and basically to remove surface distresses or distresses confined at the surface, and or to re-level the surface, provide a better bond to the proposed asphalt overlay. Another is the hot in place recycling, and that is simulated as a new asphalt layer. The cold in place recycling is also simulated as a new asphalt layer if it is designed as a dense graded asphalt layer. And then full depth reclamation is simulated as a new flexible pavement. The simulation is obviously dependent on the amount of additives that are included for the cold in place as well as the full depth reclamation. In addition, the existing asphalt is simulated based on the amount of bottom-up cracks that remain in the flexible pavement, if any, after the pre-overlay repairs and or surface modification option. So also when the cold in place recycling layer and or full depth reclamation layer are not designed as a dense graded asphalt layer, the design approach will be discussed individually for these two conditions later within the module. So if these two rehab strategies, the cold in place recycling and the full depth reclamation, are not designed as a dense graded layer, then they are considered as a new flexible pavement, and how the layers are simulated will be discussed later on in Module 9. So this basically concludes Part A of Module 9 on basically an introduction and condition assessment for rehabilitation design of flexible pavements. Part B, which is the next part, will then open the software and identify some of the differences between flexible pavement rehabilitation design and new flexible pavement design. And after opening or going through the Pavement ME software for rehabilitation, then we will come back to the presentation for Part C and go through a more detailed overview, detailed discussion, explanation of the different inputs and how they're used in rehabilitation design.